So the next topic we're going to cover are suppressing operators in the Flux class. And you'll see that there's 3 of them we're going to talk about: filter, take, and then. And suppressing operators will create either a flux or a mono that will change or ignore all or portions of its payload. So they suppress the output of values from fluxes that we're going to talk about here. So let's start by talking about the most obvious one. This is a very common one. You've been exposed to something very similar with Java streams, and that's the filter operator, which will evaluate each source value in whatever flux is passed in as when we do the filter call, and it'll compare it against the predicate. The predicate is a parameter, which is a functional interface in Java, and it'll either return true or false. If the predicate succeeds, it returns true. If the predicate fails, it'll return false. And as you can imagine, filter will only allow values that pass the predicate, in other words, return true, to be emitted. Otherwise, it'll suppress things that don't match the predicate. So if the predicate fails, the value will be ignored, and it'll request the upstream to send the next value for the next check. It returns a new flux that contains only the values that pass the predicate test. And here's a fun little visualization demonstrating a filter where you've got something that'll filter out big chunks of something. Let's say it's flour or sugar or whatnot, or gold. The number of elements that are returned from filter could be less than the number of elements that it receives, because if something doesn't match, it won't be emitted. So here's a very simple example where we're going to generate S-max iteration random big integers, and then we're going to only emit odd numbers. So this is a little filter, which, believe it or not, is going to take a big integer and check to see if the big integer modded by 2 equals 0. And if it does, that means that it's an even number, so we're going to negate that, so it's only going to take odd numbers. That's the way you check to see if a big integer is odd or even. So we're only going to emit odd numbers. Note that filter can't change the type or value of the elements it processes. That's very much like we just talked about with the action operators, like do finally or do on complete or do on next, do on error, and so on. RxJava has a filter operator that works exactly the same way for the same purpose. All these things are very, very, very similar to Java's filter operation on Java streams. Here's a similar way of checking to see whether a value is odd or even by anding the final bit by 1 to determine if it's odd or even. And in this case, we're only going to accept things that are odd. We don't do that for big integer just because they don't quite have the same representation, but we can do that here for integers or longs by using this bitwise technique. So that's filter, very common. You will undoubtedly use it. Let's talk about take next. So take, as the name suggests, only takes the first n values if there are n values. If there's less than n values, then it'll take whatever it can, but it'll take no more than n values. It should probably be called take no more than or something like that. The parameter is the number of items to emit from the flux, passed in as a long, and it returns a flux limited to size n. Anybody here who's into Greek mythology or was a fan of the Rick Riordan, Percy Jackson books or the TV show or the movies or whatnot, there's a character in Greek mythology that is called Procrustes, and he is famous for being an innkeeper who had this kind of interesting little model where he would give you free lodging in his inn, but you had to be able to fit into his Procrustean bed. And so if you were too long, he would chop you up. If you were too short, he would stretch you out. So that has led to the phrase Procrustean bed, which means something that's a sort of a force fit. So this is what we're doing with take. We're fitting things to the Procrustean bed of size n. We commonly use take to limit streams that would otherwise be infinite. Now we're going to talk about the interval operator. I think actually because this comes later now, but when we talk about the interval operator, you'll see that the interval operator is going to emit values that will occur at a particular interval, and we're going to generate an infinite sequence of integers at some millisecond duration, every n milliseconds will generate this forever, but we don't want to do this forever, so we do it up until we do take S max iterations. So we're only going to process S max iterations of values emitted from interval. RxJava has something that's very similar, although interval works in a slightly different way, but same idea. All these operators are similar to the limit operation in Java streams. Here's an example where we're going to iterate from 1 to forever, basically getting odd numbers, but limiting ourselves to the first 100 odd numbers and creating a list. So that's the way you do this kind of stuff with Java streams. The third and final suppressing operator is quite different from the others. It's actually somewhat weird, and you're wondering, why is this even useful? It turns out it's incredibly useful, but it's still very weird. It's the then operator. And what this says is, let this flux complete, and then play signals from the provided mono. So the mono is passed as a parameter with the funny name other, and it is the mono, it's the value, the reactive type to emit from after all the flux operations have completed. So the way the semantics of then are is says, ignore all the elements from this flux and transform its completion signal into the emission and completion signal of the provided mono. That's very much a suppressing operator, suppressing all the things the flux did, and then it's going to emit something else. And it returns a new flux that waits for the source completion and then emits from the supplied mono. And I was trying to think of, like, how do you visualize this? So I asked ChatGPT to do it for me. And it came up with a pretty cool visualization. So we have this, like, stream of fluxes that are emitting stuff. And then at the very end, we emit the mono. So I'm like, all right, it's pretty good. The other thing I was trying to think of, I couldn't find a good representation of this, and ChatGPT wouldn't do it, probably for intellectual property protection reasons. If you ever see the movie Rogue One, you remember that all the people are trying to get the plans to destroy the Death Star onto the ship to launch before the Empire can capture them. So it's like all those brave rebels who sacrificed themselves and were suppressed. They're the flux elements. And then what they do at the very end to get the plans off to the rebels, to Obi-Wan Kenobi and whatever, with R2-D2. I think the way it works is they launch a probe drone or something that has R2-D2 on it, and then he ends up on Tatooine. Anyway, I'm getting off topic, but it's a very cool scene. If you haven't seen Rogue One, the very end of Rogue One is super cool because it segues right into the beginning of A New Hope. So that's the other thing to think about if you don't like this visualization. So the data suppressing operator replaces its payload with another, and so here's an example. And we're going to actually walk through this when we get into the case study here in a minute. But basically, we're going to generate a bunch of values, check to see if they're prime. And then when we're all done with everything, we're going to ignore everything, all the values, and we're going to simply emit the asynchronous operation, which will print the results. So that's the final thing we do as we leave. This is also a way to connect in with the async task barrier framework. RxJava doesn't really have an equivalent to then, although it has this thing called a completable that can be used in a somewhat similar way. And you can use something called observable ignore elements, which returns a completable that ignores the values and then will signal on complete or on error. That's really getting a bit ahead of ourselves here, but there's another way to do this, and I leverage this in my implementation of the async task framework for RxJava. These things are all similar to Java completable futures then run method, which is, again, somewhat esoteric, but it has basically the same semantics. It'll be used at the end of a sequence of asynchronous actions to sort of complete things with some type of side effect. So that's the end of the suppressing operators in the Flux class.